April 18, 1957, 8:30, Greenwich Mean Time. A Vickers Viscount 701 sits at Gate 6, London Heathrow Airport. Registration, G-ALWF, British European Airways. Flight BE412 to Amsterdam Schiphol. Captain Richard Thompson completes his walk-around. 81 feet from nose to tail. Wingspan, 93 feet. 4 Rolls-Royce Dart turboprop engines. 1,600 shaft horsepower each. 4 bladed propellers, turning constant speed. The Viscount weighs 64,000 pounds at maximum takeoff weight. Fuel capacity, 4,000 gallons. Seating, 47 passengers in single-class configuration. First Officer Michael Davies checks the distinctive oval windows, larger than any previous airliner. Flight Engineer John Harrison monitors systems from the sideways-facing panel behind the pilots. This is Turboprop Aviation. This is the Viscount. The Revolution Vickers developed the Viscount in response to a 1945 Brabazon Committee requirement. Short-range transport, better than piston aircraft, not quite jet speed, but smoother, quieter, more efficient. The solution? Turboprop engines. Rolls-Royce Dart power plants, gas turbine driving reduction gearbox, gearbox turning propeller, jet engine power, propeller efficiency. First flight, July 16, 1948. The prototype flew with Dart engines producing 1,200 shaft horsepower. Later production models increased to 1,600, then 1,800 shaft horsepower. BEA ordered the type. Entered service, April 1953. London to Cyprus. The world's first turboprop airliner in commercial operation. The passengers noticed immediately. Vibration-free flight. No reciprocating engine shake. Smooth turbine operation. Quiet cabin despite propellers. Pre-flight systems. Thompson examines each Dart engine. The power plant is compact, efficient, revolutionary for 1957. The Dart operates differently than piston engines. Continuous power delivery, no reciprocating motion, centrifugal compressor, combustion chamber, turbine driving both compressor and reduction gearbox. The propeller turns at constant speed, typically 1,300 revolutions per minute. Power changes come from turbine temperature and fuel flow, not RPM variation like piston engines. Davies inspects flight controls. Hydraulically boosted, manual reversion available, triple redundant systems on critical components. Harrison checks fuel system. 4 wing tanks, 2 inboard, 2 outboard. Cross-feed capability. Balanced fuel management critical for maintaining center of gravity. Cockpit configuration. The flight deck seats 3. Captain left. First officer right. Flight engineer behind and between them. Harrison's panel manages engines. 4 columns of instruments, 1 per Dart engine. Turbine temperature, fuel flow, oil pressure, propeller RPM, exhaust gas temperature. Navigation equipment includes VOR, ADF, and distance measuring equipment. The autopilot handles basic functions, but requires constant monitoring. Everything analog, everything mechanical, everything proven. Passenger boarding. 47 passengers board through forward and aft doors. The Viscount cabin offers unprecedented comfort for 1957. Large oval windows. Natural light floods the cabin. Better visibility than any previous airliner. The turboprop engines sit far enough outboard that cabin noise remains minimal. Passengers experience smooth, vibration-free flight. 4 abreast seating. 2 on each side. Good legroom. Overhead storage, modern amenities for the era. Cabin crew, 3 flight attendants, prepare for departure, safety demonstration, passenger count, galley preparation. Engine start. Harrison initiates start sequence. Engine number 1, the outboard left Dart. High-pressure air from ground cart spins the turbine. Fuel valves open. Igniters fire. The engine lights with smooth turbine whistle. The propeller begins turning, slowly at first, then accelerating to governed speed, 1,300 revolutions per minute. Constant, smooth. Engines 2, 3, and 4 follow. 4. Dart turboprops running. The sound is distinctive, higher pitched than piston engines. Smoother, more refined. Ground crew disconnects external power. The Viscount operates on internal generators now. Taxi Thompson receives taxi clearance. The Viscount moves smoothly. Good nose-wheel steering, excellent forward visibility. The turboprop engines respond instantly to throttle inputs. No lag like piston engines. Immediate power, precise control. At Heathrow, the Viscount shares space with Douglas DC-3s, DC-4s, and early jets. Aviation in transition. Turboprops bridging piston and pure jet eras. Takeoff runway 28 left. Wind, light westerly. Temperature, 12 degrees Celsius. Final checks complete. Harrison verifies all 4 darts producing proper power. Thompson advances throttles. The Viscount accelerates smoothly. No vibration. No reciprocating engine roughness. Pure turbine power transmitted through reduction gearbox. 80 knots. 100 knots. At 110 knots, Thompson rotates. The nose lifts. The main gear follows. The Viscount climbs at 1,200 feet per minute. Excellent performance for full passenger load. Gear retraction. Flap retraction. Clean configuration achieved. Climb to cruise. The Viscount climbs toward assigned altitude, 15,000 feet. Standard for European routes in 1957. Davies handles communications. Harrison monitors engines. Thompson flies. The Dart engines operate most efficiently at altitude. Fuel consumption decreases. Speed increases. Range extends. Climb speed, 160 knots. Smooth. Steady. The passengers barely notice the ascent. Cruise operations level at 15,000 feet. Speed, 280 knots. Efficient cruise for the type. The Dart engines run at continuous power settings. Turbine inlet temperature monitored carefully. Fuel flow adjusted for optimal efficiency. London to Amsterdam, 200 nautical miles. Flight time, approximately 45 minutes. Davies navigates using VOR stations, radio beacons along the airway. Standard procedures for 1957 European operations. The autopilot maintains heading and altitude, but requires monitoring. Early autopilots lack sophisticated features of later systems. The turboprop advantage. Over the North Sea, the Viscount demonstrates its strengths. Fuel efficiency better than pure jets. Range adequate for European routes. Speed significantly faster than piston aircraft. Operating costs lower than early jets. Maintenance simpler. Reliability excellent. The Dart engine proved remarkably durable. Time between overhaul, thousands of hours. Far better than piston engines requiring frequent cylinder work. For airlines, economics made sense. For passengers, comfort exceeded expectations. For crews, smooth, predictable operations. Descent and approach. Air traffic control clears GALWF for descent. Thompson reduces power. The Viscount descends smoothly. Harrison monitors engine temperatures during descent. Turbine engines require careful management during power reductions. Avoid rapid cooling. Approach to Schiphol. The airport sits below sea level. Flat terrain. Good visibility today. Davies configures for landing. Flaps extending. Landing gear deploying. Speed reducing. Thompson stabilizes on final approach. Speed, 120 knots. Sink rate, 700 feet per minute. Landing. The main gear contacts the runway smoothly. Thompson deploys reverse thrust. Propeller blades change pitch, directing thrust forward. The Viscount decelerates, speed decreasing, nose wheel lowering to runway. Normal braking. The aircraft slows, turns off at taxiway Bravo. Tower directs GALWF to gate 4. The Viscount taxis smoothly through Amsterdam morning. Shutdown engines shut down. 4 darts winding down. propellers slowing, the turbine whistle fading, external power connected, passengers deplaning, ground crew positioning stairs, Thompson, Davies, and Harrison complete post-flight paperwork. Another successful Viscount flight complete. The legacy. The Vickers Viscount served commercial aviation for 4 decades, from 1953 to the 1990s in various roles. 445 aircraft built. Airlines worldwide operated the type. BEA, Trans-Canada Airlines, Capital Airlines, Continental, Lufthansa, dozens of others. The Viscount proved turboprop viability, showed the technology worked commercially, paved the way for Fokker F-27, Convair 580, later turboprop development, not through revolutionary design, through solid engineering, reliable dart engines, practical configuration, real operational advantages, the aircraft that made turboprops mainstream, that brought smooth, quiet flight to regional routes. That proved the technology between piston and jet eras. Still remembered by passengers who flew it. Still respected by crews who operated it. The first, the foundation, the Viscount.